Now, a definition. Definitions are, ministry questions, and this definition is also a ministry question. First, I'm going to read the definition, then I will explain what it is. This explanation is what definition of the path length difference. In fact, you can predict. One wave travels longer than a distance longer than the other one. So difference between these lengths is called path length difference. For example, in here, S1 travels a longer distance than S2. How much longer? How much longer? 1 lambda. That 1 lambda is called path length difference. Yeah, one wave travels a longer distance than the other wave. How much longer that distance? Which is called path length difference. Get the difference in distances. Then you are going to subtract L1 and L2, which tells you one wave travels longer than the other one. How much? Difference in distances, L1 minus L2, traveled by 2 waves. Yes, 2 waves. When they are scattered, scattered means sent. They are sent from different sources. Yes, these waves are sent from different sources. Difference between these lengths called path length difference. They didn't give you this definition in this exam question. They give the definition to you and ask you what is this. The difference in the distance traveled by 2 waves or beams when they are scattered from different sources is called coherence, interference, path length difference,
Yes.
phase angle difference.
No.
Length diyorsa length'tir. Because angle, difference is angle. Okay. So, the path difference determines whether 2 waves are in phase or out of phase. If a wave travels 1 wavelength longer, they are in phase. 2 wavelengths longer, again in phase. 3 wavelengths longer, again in phase. Or if 1 wave travels lambda over 2 longer, out of phase. They will read on the screen, out of phase. 1.5 wavelength longer, again out of phase. 2.5 longer, again out of phase. Yani path length determines if the waves meet on the screen in phase or out of phase. Path length difference determines if the screen, the point is bright or dark. Okay? So I draw 3 cases in here. First case is center. Center is bright. Why? Because travel distance by the waves are same. Yeah, the path length difference is what in this case? What is path length difference now? 0. Both travel 6 lambda. We count them. 6 lambda. And one, this wave travels 6 lambda, that wave travels 6 lambda, and path length difference is 0. Yes, 6 lambda minus 6 lambda, 0. Path length difference is 0. What about path angle difference? 0 again. What about this? One wave travels longer than the other one. How much longer? 1 wavelength longer. So, path length difference is how much? 1 lambda. What about path angle difference? 1 wavelength corresponds to 2 pi. Each lambda corresponds to 2 pi. Don't forget this. We did this before. 1 wavelength corresponds to an angle which is equal to 360. Yani 2 pi. So, path angle difference is going to be 2 pi. What about that? This is first dark, huh? First dark. One wave travels longer than the other one by lambda over. One wave travels lambda over 2 longer than the other one. So path length difference is lambda over 2. So for first dark fringe, path length difference is lambda over 2. Okay? Corresponding phase angle difference. How much? Pi. Just write here pi divided by 2. 2 pi divided by 2. 2 pi divided by 2? Pi. Instead of lambda, right? 2 pi. Because each lambda, 2 pi. So 2 pi divided by 2 pi. Phase angle difference for the first dark fringe is only pi, 980. Now we are going to make a table. Table for all. Yes?
Why that one is not 0?
Because distances are equal. 1 lambda, 2, 3, 4, 5, 6. 1, 2, 2, 3, 4, 5, 6. 6 lambda minus 6 lambda.
0.
0, 0. For central bright fringe, path length difference is 0. Path angle difference is also 0. For first bright, path length difference is lambda. Phase angle difference is 2 pi. Yes, path length difference determines whether two waves are in or out of phase when they combine at the screen. If they are in phase, constructive interference happens. If they are out of phase, destructive interference occurs. So now, if path length difference is 0, a phase angle difference also 0. This is central bright fringe. If path length difference is lambda, corresponding phase angle difference is 2 pi first bright fringe. If path length difference is 2 lambda, corresponding phase angle difference is 4 pi second bright fringe. If path length difference is 3 lambda, corresponding angle is 6 pi, it is third bright fringe, and so on. What does it mean? If path length difference is some whole number multiple of wavelength, whole number is what? 1, 2, 3, 4, 5, 6. Whole number, yes? 0. 1 lambda whole, 1. 2 lambda, 2 whole. 3 lambda, 3 whole. 4 lambda, 4 whole number. Whole multiple of wavelength. So in this case, these points are representing bright fringes, and all, at those points, constructive interference takes place. But if path length difference is 0.5 lambda, and lambda over 2, corresponding NF phase angle difference, pi. 1.5 lambda, yani second dark. Corresponding phase angle difference, 3 pi. 2.5 lambda, third dark. Corresponding phase angle difference is 5 pi. In general, when the path length difference is odd multiple of half wavelength, odd multiple, 1 and a half, yani odd multiple. For example, 0.5 is 1 times 0.5, 3 times 0.5, 5 times 0.5, 7 times 0.5. And you are going to multiply 0.5 by odd numbers. So in this case, you will get the points at which destructive interference happens, so dark fringes. And these statements are important because they're just removing this part and us writing them, so which one's correct. Or they are removing this part and then putting choices for that. Okay. Now we will solve some problems. If you miss your exam questions about them. Everything is clear?
Yes.
For example, question number 1. Which of the following must be true for two waves which with identical amplitudes and wavelengths to undergo complete destructive interference? For complete destructive interference, wave must be out of phase. Why 180? So choices is, which choice is correct? They must be 180 degrees out of phase at all times. C is the correct for complete destructive interference. Different angles possible. It can be dimmer light, but not complete destructive. Yeah, it can be 90 for dimmer light, or 270 for dimmer light. But for complete dark, complete destructive, they must be out of phase by 180. Yeah, crest and trough must meet, they must cancel. Okay? Question number 3. What is the necessary condition for path length difference between two waves that interfere destructively? A. An odd integral number of half wavelengths. This is the correct answer. Odd integral means 1 times lambda over 2, 3 times lambda over 2, 5 times lambda over 2, This is the condition for destructive interference. Correct answer is A is correct answer. B, integral number of wavelength, which means 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, it's for constructive. C, odd integral of wavelengths. It doesn't matter, 1 lambda, 3 lambda, 5 lambda, if it's the multiple number of lambda, it is constructive. And even integral number of half wavelength, it doesn't matter. 2 times lambda over 2, 1 lambda. 4 times lambda over 2, 2 lambda. 6 times lambda over 3 lambda. Again, integral number of lambda. So all these three defines constructive interference. For constructive interference, 1 lambda, 2 lambda, 3 lambda, 4 lambda. But for destructive, 1.5, 2.5, 3.5 goes on this way. Okay? In an interference pattern, if the path difference in angle between two waves is 3 pi radian, 3 pi. So what do you think? It's constructive or destructive? Destructive. Remember, even 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, it was constructive. Pi, 3 pi, 5 pi, 7 pi, 9 pi, it's for destructive. Which destructive is this? Which dark image is this? Second. So first one is pi, second one is 3 pi. So this is second order dark. In an interference pattern, if the path difference between two waves are 3 lambda over 2, 3 lambda over 2, it is 1.5, huh? 1.5 comes after 0.5. 0.5 first dark, 1.5 second dark. Now we are going to define what is incoherent light sources. We know what coherency is. Always, phase must be same for all the time between two waves. But if phase changes by time, we say that these sources are not coherent. For example, look at it here. Are they in phase now? Yes. But now? No. But now?
Yes.
As you see, phase angle difference between these two waves are changing as time goes. Good example is two light sources. These two light sources are incoherent because they are independent from one another. To produce coherent light sources is not that easy. I'm going to hold one on my hand, other one on no, you cannot make that. Because light is changing, frequency of light is changing in 1 second, 10 to the power of 14 times. How can you make them equal at the same time, crest and crest, and trap and trap? It's impossible. You cannot make two independent light sources coherent. Impossible. They are incoherent. So, two light bulbs produce incoherent waves. No interference pattern is observed even if the lights are the same color. Assume that these lights are blue and blue. If you make them coherent, but you can't, on the screen, on the floor you are going to see bright, dark, bright, dark, bright, dark fringes. But they are not coherent. You cannot see them. So each bulb emits independent waves from one another. They are independent from one another. Thus, the phase difference between the waves are continuously changing, just like those waves. So light waves still interfere. Interference always exists between same colors, always. But one is constructive, then destructive, then constructive, then destructive. It's changing so quick. Your eyes are unable to detect this. To make it detectable, observable, what should we do? We should use two coherent light sources. So one point must be always destructive, other point must be always constructive. Now we are going to define the position of each fringe by some angle. Angle theta in here. Which is angle theta? Angle theta is the angle between the line joining this central bright fringe to the midpoint of the sources. Yeah, you are going to draw a line from midpoint of the sources till the center of the screen, which is central bright fringe form. So this line is called sometimes central line. Angle between central line and position line. What is position line? Again, from the midpoint of the sources to where the fringe is. You are going to draw another line. Theta is the angle between these two lines, which is position angle of this bright fringe. But every location of every bright fringe is different. So these angles must be different for each fringe. Let's draw it for the second bright fringe. Here is the position of the second bright fringe. Draw a line from the midpoint of the sources to where until here. What happened to the angle? Increased. As order of the fringe increases, angle theta, position angle also increases. So, as order of the fringe increases, from first to second, second to third, third to fourth, fourth to fifth. As order of the fringe increases, the position angle of the fringe with respect to central line also increases. As this theta increases, position angle increases, path length difference also increases. Look at now. Theta 1 is the position angle of the first bright fringe. Theta 2 is position angle for second bright fringe. Which angle is greater? Second one. L1 minus L2 is path length difference for the first bright fringe. L2 minus L4 is the path length difference for second bright fringe. L2 or L2 minus L4 is greater than L1 minus L2. Yani as angle increases, path length difference also increases. As angle increases, path length difference also increases. So L1 minus L2 is the path length difference for the first bright fringe. Theta 1 is the position angle for the first bright fringe. L2 minus L4 is the path length difference for second bright fringe. Theta 2 is the position angle of the second bright fringe. Because theta 1 is less than theta 2, L1 minus L2 is less than L3 minus L4. So then we will say that as position angle increases, path length difference also increases. Yeah, the path length difference depends on position angle. Okay. And now this is position of a fringe. From S1, source 1 to this position, path length is L1. From source 2 to that position, path length is L2. Of course, L2 is longer than L1. So then there must be a path length difference. I'm going to try to find an equation. As I said, path length difference changes by the angle. Huh? I want to write an equation related with the angle and also separation between the sides. But I can't do it mathematically. Only I have to draw a perpendicular line from the source 1 to L2, because L2 is longer than L1. When I draw this dashed line, perpendicular distance, this length and that length becomes almost equal. Almost. What does it mean? That additional length is going to be path length difference. Which one is longer? L2 is longer than L1. If I draw a dashed line perpendicular to this one, this length and that length becomes almost equal. In this case, this additional part is going to be difference in lengths. And here, that length is going to be the path length difference between L2 and L1. How can I calculate that length in terms of distance, separation between the slits and theta? Is this a right angle triangle? Yes, it is. Is distance between the sources, which is the hypotenuse? Yes. Whatever this angle theta is, that angle is going to be same. Theta, theta. This angle and that angle mathematically equal. So now look at that. Path length difference is the opposite leg of this right angle triangle. Is the opposite leg? Opposite leg is calculated by hypotenuse times sine theta. Yes. Hypotenuse is d. Multiplied by sine theta. D sine theta is going to be path length difference equation. d sine theta is going to be path length difference equation. Yani I don't need to measure L2 anymore, and L2 and L1. Just I am going to check how much is this angle and what is separation between the slits. Then d sine theta will give me the difference in length between L2 and L1.
This equation is only for the addition part.
Yes. Yeah, this additional part is the length difference in length. So then if I ask you, what is the equation for path length difference? D cosine theta?
No.
D divided by sine theta?
No.
Sine theta divided by D?
No.
D sine theta?
Yes.
Okay. Now instead of path length difference, from now on we are going to talk about D sine theta, because from now on we are going to define path length difference in terms of separation between the solids D and position of the fringe with respect to central line. Then, if path length difference is equal to d sine theta, now I'm going to revise that table which I gave you. What was that table? It says, if path length difference is whole integer of lambda, construct an interference happens. Yani, if path length difference and d sine theta, from now on I add d sine theta. If path length difference d sine theta is equal to 0, it is central line fringe. If path length d sine theta is equal to lambda, first. If d sine theta is equal to 2 lambda, second. If 3 lambda, third. Yani basically, if d sine theta is equal to m times lambda, which m is 0 for central bright fringe, m is 1 for first bright fringe, m is 2 for second bright fringe, m is 3 for third bright fringe. D sine theta is equal to m times lambda is equation for calculating the given for bright fringes. For dark fringes, we know that d sine theta must be lambda over 2 for first dark, 2 lambda over 2 for second dark, 5 lambda over 2 for third dark, 7 lambda over 2 for fourth dark, and so on. In general, now if I want to write an equation, d sine theta is going to be m plus 1 over 2 lambda. M is 0, 1, 2, 3, and so on. However, this 0, 1, 2, 3, and 4 does not indicate the order of dark fringe. Order must be 1 greater. Yeah, instead, if you write 0, order is 1 greater first order. Yeah, this is for first order, this is for second order, this is for third order, this is for fourth order, and so on. So, if the question is that, okay, write the equation for path length difference equation for first order. Instead of m, you are going to write 0. For second order, instead of m, you are going to write 1. For third order, 2. For fourth order, you are going to write 3.